So the idea is very simple. You just add your friend to an email, add Amy at x.ai as well, send x.ai the email, and we'll now respond and reach out to other people on your behalf as a normal human assistant would. Amy can propose times, pick up a preferred location for you. She can get a phone number based on the type of meeting, and you're able to change all of these preferences on our customer-facing applications. We'll also do things like reschedule the meeting. If they have an assistant, we'll reach out to follow up with them. So all of this happens in the back end. You don't know anything. The next thing you'll see is an invite on your calendar from Amy at x.ai or Andrew at x.ai. So now let's go a little bit about the email pipeline. I don't have an architecture diagram with me today, but if you can imagine a nice, clean infrastructure where everything's handled between queues, we'll receive an email from our Mailgun email provider. That goes into an SQS queue. We start extracting information, which dumps into another SQS, which is simple queue service. Then that goes into another queue, another process that needs to extract context, meetings, who's in the meeting. That goes into another queue again and again, you can imagine. So we basically have a data pipeline split up between SQS. Sounds great, very simple. A response goes out at the end. Unfortunately, we've been working on this for 4 years. We didn't just build this today, so there's some amount of tech debt in the system. We're also integrating with all kinds of third-party APIs along the way. We're talking to Exchange Server, Office 365, Gmail, Google Calendar, all these things that we want to serve in addition to just responding to emails. We're also launching new features every day. We're making updates to the pipeline. We want to be able to do continuous deployment. And so, sometimes it's hard to make sure the health of your system when you've got all of these things talking to each other through a queue, right? It's a little bit different when you're making a bunch of web service talking to each other. A lot of third parties like New Relic can just instrument that for you automatically. But how do you keep track of an email when it's going from 5 to 7 different queues and you make sure you actually get a response? That's the most important thing we care about. What we've done in the past is we have a general idea of the average response time in the system, and if that goes up, you get an alarm. But as soon as you get an alarm now, you have to dig through all of the different graphs, the service metrics for every individual component, and figure out what's going on. And then once you fix it, you have to make sure that we actually picked up all those individual messages. So how do you track those make sure that every message gets through the pipeline? So that was what we were trying to solve here. We also wanted to find a solution that's easy to understand and implement. So if we wanted to add another component tomorrow, a developer should be able to find some documentation, quickly set something up in their test environment, and deploy to production, and add this to the rest of our metrics. In addition, we also have a customer service team. So if a customer complains or is asking, where's my email, or we saw something on your status page, we wanted non-engineers to be able to go in and understand what's going on in our system. So before I get into X-Ray, I'll talk a little bit about some of the alternatives that we talked about. The first one was using Kinesis. It sounds like a really cool piece of architecture that Amazon offers. It's basically, it's easy to send data. You can send lots of data, gigabytes or terabytes of data. And a great use case of Kinesis would be something like a log service, if you wanted to aggregate logs. The downside was we found that this was a lot of moving pieces. If you had to, once you sent stuff to Kinesis, you needed to use Kinesis Analytics to pull that out as a stream and then pipe that to Elasticsearch. And we weren't using Kinesis anywhere in our system, so we thought that would be a lot of work to explain to all of our engineers on how to use it. I also suggested we build something ourselves. We know how to build a little web app. We know how to store something in the database and query it. We're really good at this, so why not do that? The downsides, of course, is that you need to monitor this thing. You need to make sure it's up. It's easy to change. You need to document it, test it. So now you're also managing your own monitoring system. We also considered using simple notification service plus SQS. Instead of apps actually sending information to SQS, you have them publish it to SNS. This allows you to have multiple readers along your pipeline. And the way we would implement that is have some consumer on every SNS topic aggregating the information for you. But you still have the problem that you're going to need to document this, maintain it, and make sure it's working. X-ray to the rescue. So we sat around a little bit more. We were going down the Kinesis thing. We spent about a week on it, and it kind of was working. We still had a long way to go. So we called up our friends at AWS, said, look, we're just piping stuff through SQS on a data pipeline. How do other people make sure that their data pipeline's working? They suggested take a look at X-ray. It was really surprising to me because of all my Google searches, I was never able to find this thing. So that was one takeaway for us. Just talk to your friends at AWS and ask what services are available for your problems. Some of the really cool things that we got from X-ray, we found that this was one layer of abstraction above Kinesis. Instead of building our own analytics pipeline, X-ray is designed for you to send these traces from any point in your system, and you can add metadata, such as a unique ID that's from your database, or if you have errors that happen that from a third party. You can also add the environment. All kinds of things that allow you to search through these traces later on and aggregate the information easily. They also provide SDKs with Node.js, Go, Java, Python, maybe some others, which again makes it very easy for developers to jump in and start using it in their own applications. And one other really cool thing I'm going to show you is they also automatically will generate a chart of your infrastructure, of the services you've instrumented. So here's a screenshot of our infrastructure. This is our email pipeline. You can see how hard it was to monitor this thing just looking at a bunch of trend lines. This was actually a snapshot taken last week. Our email provider Mailgun was having authentication issues, and you can see down there the little red circles. One is our service, and the Mailgun's the other service, and we were able to easily see that where the issue was in our pipeline when our alerts started going off. And then you can drill into each service, and inside of each service, you can see where these messages are actually happening. So if you've ever done web browser development, this looks really familiar. It's just a waterfall of loading times and where a particular email has gone. So it makes it easy to see where your bottlenecks are, how long each component in the system is taking, and if it got stuck, where it was last seen in the system. I'm from an arts background, so for me, this is like magic. We showed this to our engineers once we had it set up for the other engineers, and it's been eye-opening. It's actually, I think people are feeling a lot more comfortable working on the pipeline who haven't worked on it before. So nothing's perfect. I'm going to talk a little bit about some of the gotchas that we ran into across the way. When you want to retrieve this information, so for us, we are using Datadog to create our monitors, to create a dashboard so we can actually see what's going on. And if we want to send alerts, it's always coming from Datadog. To get it out of X-ray, we needed to actually build our own script. We're using AWS Lambda, it's just polling every 5 minutes, and then sending that forward. In addition, when you're trying to search for a specific message, the only way to do that in Amazon's console today is by looking at 6-hour windows. So that works great if this incident just happened, but what do you do when it happened 2 days ago? You actually end up having to like move the 6-hour window back until you find the right message when you're searching for metadata. Not a big deal, but it's something that we ended up building our own interface for and having a back-end job that would just pull these windows and aggregate them for you. Sending data from an app is pretty straightforward, but when you actually want to make sure that you're tracing the same message across all these pipelines, you want to make sure that you have the original trace ID. And if you want to actually get the nice visualization here where each service is pointing to the next service, you have to keep track of what they call the parent ID of the service before you. So that part it was a little more manual. It wasn't out of the box with their SDKs. But in the end, I think it took about 2 weeks for 2 engineers full-time to instrument all of our applications in Python, Scala, and Node.js on the back end. And about another week adding this information into Datadog, creating the dashboards and alerts. So some final tips. Read the documentation. This was one of the big benefits of using X-ray. They have great documentation. They explain all the different concepts. I highly recommend it. And if you have new engineers who want to learn how this thing works, I can just send them to the documentation. Be prepared to test and tune the implementation. It's really good to do this in a staging environment first, because you will be adding instrumentation on the endpoints of your applications, which are the most fragile and critical. And we also ended up writing our own wrappers around the SDKs for applications. So it makes it easier when a developer's writing something in test or staging that they're using our wrapper, which knows you're in testing and won't send the data into production accidentally. And it also helps us enforce the types of metadata we're sending. That's all I've got today. My name is Matt Casey. We are hiring at x.ai. We're looking for full stack engineers and backend. Come talk to me after the talk or visit our website, x.ai, join the future. Does anyone have any questions?
When I apply, is that all automated? Am I talking to your assistant when I go through the application process?
No, we'll
yet.
Put a little human touch on it right now.
All right, who wants to kick off with first question? There's a lot to cover. There we go. He had it first, and you be second.
Is there a way to tag, say, test traffic so that you're not including that in your X-ray results? Or to target it?
We're using the metadata to actually add like an environment field. And so we actually can filter that. But that, again, that's enforced in the library. So that way I don't have to tell every engineer, like, oh, add this little environment field. You have to come up with your own solution.
So you mentioned you have some Scala apps. I was wondering if you guys are using Akka, and how you instrumented if there was like a bunch of Akka workers or actors in your environment.
I actually can't speak too much on the details of in the Scala how we're implementing it. I was working on the Node.js side. But I know there was a little trouble getting the threads to keep track of the trace IDs, because you create the segment, but then you need to actually close it at the end, and you need to keep track of the segment ID that you created. Whereas with Kinesis, it was nice. You just sent like, here's my message ID, and I'm starting, and then here's my message ID, and I'm done. And then you're using SQL to aggregate that information for you. The way with X-Ray works, you have to keep track of your segment. You have to make sure you send it at the beginning and at the end. But once you get it, it's great.
How much of this is having to instrument your code versus this being available automatically? Like, can you say just click something and enable a Lambda to send traces?
So I believe Lambda and SQS does have integration with X-Ray, but there you're not going to be able to see, like, say, what email was being processed by that Lambda function, unless you actually go into your code and say, I have this message ID, this is the information I'm caring about.
Okay, so basically, you have to instrument your code heavily, go through the entire...
I think there wasn't really any way around it.
Okay.
If you just want high-level service metrics, their SDKs are powerful enough. If you have an express service in Node, you just say, monitor this, one line of code, and you're done. And then you can see your service talking to all the other services.
So it's not a problem that your code base is heavily tied to X-Ray API? It's not
well, that's why we created these wrappers. So there's just a few key places where you're saying, create a segment, close the segment. Create a segment, close the segment, add an error. About 3 lines of code, and you make sure it's working. Again, it's hard to make sure it's in testing, and that's why we have a standardized library that we're sharing in our languages. One additional thing I forgot to add is the way it's working is we have a daemon running that you host yourself. So all your apps are actually talking to the daemon, which then pipes it to X-Ray. I actually like this setup because then your applications don't need authentication. They're just sending some data to a local host or on the machine at a certain port. And the daemon handles all the rest of it.
Did you find that this made a tremendous amount of logs, and how'd you have to handle that?
I'm sorry, I couldn't hear you.
Did you find that this made a tremendous amount of logging in your app, and were you prepared to handle it already, or did you not have to deal with that?
So there's actually no logging involved. That's the idea, right? You're actually just saying you're submitting an event over TCP with some metadata, and then that X-Ray Amazon service is aggregating all those logs for you. Yeah.
Did you evaluate open tracing, and why X-Ray over it, if so?
Open trace? No, we didn't. So.
That was a short answer.
But if you want to talk later, we could share notes if you're looking at open trace too.
I was wondering if you could elaborate a little bit more on the kinds of metadata that you're passing along, or like how you're using additional custom metadata inside of X-Ray to keep track of everything.
Like what other things are we using with metadata?
Yeah.
So we have, well, we're using environment. Every email has a unique message ID. We're also saving that. If we have an application that also filters spam, so if that application decides finish this email, it can actually add metadata about the reason that we finished it, like the spam, the reason we blocked it as spam, which is another thing that a customer service person can come in and query that, and they'll see, oh, this trace was blocked as spam. So now we're actually not needing to go to logs anymore. Your key information is all inside of X-Ray. Another thing concept we've kept around is this field called action needed. So you can see we received this email from Mailgun. We don't count ourselves against Mailgun. This is when someone sent it from their client and then it got to us. We want to know specifically at this point in the system to like say when we actually sent it out, what is that response time? So we're adding some additional flags like, okay, we need an action and then we're done with the action. And we're monitoring on that. And that allows us to separate our processing from external third-party processing.
Cool. Well, thank you very much. I assume you'll be around to answer more questions.
Thank you.